Swayam Prabha. Digital India. Educated India.
Welcome to the lecture on data preparation module. Let's have some quick recap on what we have done earlier in the data wrangling part. We have read the data from different file formats. We have looked for duplicate records and removed duplicated observations across all the data sets. We have also checked if all the observations in the data are unique or not. So, in this lecture, we are going to join 3 files. We are going to understand the basic structure of the data, followed by the data cleaning part. So, first we will start with joining the files. So, to join 2 files together, we use the function called full join. What full join does is, it combines the data frames, it will retain all the values. If in case there are missing values, it will retain them as NA. So, let us look at the syntax of the full join function. So, x is one data frame and y is another data frame. We can use the full join function to combine x and y. So, here we can combine the y to the existing data frame called x through a common identifier y. So, to use full join function, you need to load the library called dplyr using the command library of dplyr. So, here I am using the function called full join, where x is one of the data frame, that is AC details, and y is another data frame, demo details. Here we are going to join the 2 files using the full join function through an identifier variable called customer ID. Because we know customer ID is common across all the 3 data sets, so we are going to use this customer ID as a common identifier variable. So, here we have joined AC details and demo details, and we are saving that to a data frame called churn. Similarly, we can join the service details to the existing data frame called churn using the same full join function. So, now x will be my existing data frame, that is called churn, and y will be the data frame to be joined, that is service details, through the same common variable called customer ID. So, now this churn will contain all the information across all the data frames. So, when we look at the environment tab, you can see churn has 250 observations with 21 variables. So, this 21 variables has come from AC details, demo details and service details. So, now we have joined the 3 files. So, to understand the data even more better, we can use the function called str. This will give you the structure of your data frame. So, the input should be your data frame. So, here we are going to see whether the variables are of expected data type or not. If not, we are going to coerce them to the expected data type. So, let us look at the syntax for str command. So, the input should be your object, that is nothing but your data frame. So, to get the structure of the data, you can use the command called str followed by your data frame name, that is churn here. So, this is the snippet of the output, which will give you a few lines of the output. That is basically it will giving you the first 6 lines of the output, but in your console you will be getting the details of all the variables. So, here you can see it is of class data frame. It has 250 observations with 21 variables. First, when we look at the first variable, that is customer ID, it is a factor variable, that is represented as factor. We have 250 observations and it also has 250 levels. So, all the levels are unique under customer ID. Next is the tenure variable. It is also a factor variable with 71 levels. So, next, if you can see paperless billing, it is a categorical variable with two levels, that is yes or no. This is to get the structure of the data frame. You can also get the structure for a particular variable using the same command. You can use the str command here. Inside the parenthesis, you can specify your data frame and you can access the particular variable from the data frame using a symbol called $. So, when we look at the structure of a phone service, it says it is a categorical variable with two levels, that is yes or no. So, now we have looked at the structure of our data frame to see what is the data type of each variables. Now, let us look at the summary command to get the summary of the object. So, summary is a generic function which is used to produce the 5-number summary for a numerical variables, and it also provides frequencies of each categories for a categorical variable. Let us look at the syntax of the summary function. The input should be your data frame. To get the summary for the data, we can use the command called summary followed by a data frame name, that is churn. You can see the output below. So, it is basically giving you the frequencies for categorical variable. For instance, under the variable paperless billing, you have 98 observations as no and 152 observations as yes. Similarly, for the numerical variable, it is giving us the 5-number summary with mean. From here, you can check the range of your total charges, that is the minimum value is 18.85 and the maximum value is 8337.45. It also gives first quartile, that tells us 25% of your data can have value less than 447. The median value of the total charges is 1337. Mean is nothing but the average value of the total charges, that is 2307, and it also gives the third quartile, that is nothing but 75% of your data can have value less than 3883. You can also see something represented as NAs, those are nothing but not available values. Now, we have encountered we have 15 missing values under total charges. So, you can use the summary command to check the frequencies for a categorical variable and the 5-number summary for a numerical variable. So, we can also get the summary for a particular variable using the same command called summary. Inside the parenthesis, specify your data frame and access the desired variable from the data frame called churn. So, here I am accessing the tenure variable from the data frame churn. So, the output displayed here, it is basically showing you the frequencies under each categories. 10 as a category, it has 5 observations, 1008 as another category has only 1 observation. You can see all the other values except 4 and 1 are represented in terms of numerical values. 4 has been represented as FOUR and 1 has been represented as ONE. This can be a typo. 4 has 9 observations and 1 has 20 observations. We are also checking the summary for the senior citizen variable from the data frame called churn. Since senior citizen is a numerical variable from our data set, it is giving us the 5-number summary. The minimum is 0 and the maximum is 1. You can also see there are 5 missing values under senior citizens, that has been represented in terms of NAs. We are also checking the dependence column. Since it is a categorical variable, it is showing you the frequencies under each categories. We have 171 observations under no and we have 73 observations under S. We have another category called 1 at the rate of hashtag, that also has 6 observations. Now, let us start by cleaning the data. So, by using the structure and summary command, we can see tenure has been read as factor instead of numeric or integer because of the values 1 or 4, which are represented in terms of strings. Senior citizen has also been read as integer instead of factor since it has values 0 and 1. Finally, we have seen the dependent column which should have only 2 levels, that is yes or no, but it has 3 due to the special character associated with that, that is 1 at the rate of hashtag. So, that it has also been read as another level. We have also seen some of the missing values present in few variables. So, now let us start by cleaning the column called tenure. So, we know that tenure has been read as factor instead of numeric data type because of the values 1 or 4. In R, we cannot manually add or remove any of the existing levels since the factors are locked. We need to unlock the factor levels, so that it is necessary to convert them to a character data type before changing the levels. But ideally, this column should be of numeric data type. To convert non-character objects into character objects, we can use the function called as.character. So, here we are going to convert tenure as character data type. To convert non-character objects into character strings, we can use the function called as.character. This is the syntax for using the function as.character. As.character is the function, x is nothing but the object that is to be coerced. So, now we are converting the tenure to a character variable. We are using the function called as.character. I am accessing the tenure from the data frame called churn, and I am reassigning that to the existing data frame by specifying the column as well. So, now we are going to replace the 4 FOUR by the number called 4 and ONE by the number 1. So, to replace that, we can use the function called if else. So, let us look at the syntax for using if else function. So, the first argument should be the condition. Basically, the if else function tests this condition. Next argument is the true. If the test condition is satisfied, it will replace the value which is specified in the place of true. If the condition does not satisfy, it will be replaced with the statement which is expressed in terms of false. So, now we are going to replace the invalid characters in the column tenure. That is, we are going to replace the strings FOUR by the number 4 and ONE1 by the number 1. So, here I am using the function called if else. The first argument is the condition, that is wherever the tenure is equal to FOUR in the data frame churn, it will be replaced by the number 4. If this condition is not satisfied, then it will remain as it is, and I am saving that output to the existing data frame, that is churn. And now we are converting the tenure to numeric data type after replacing the values. So, to convert them to a numeric data type, we can use the function called as.numeric. We can specify the data frame followed by the variable and save that to the existing data frame followed by the variable. So, now let us look at the summary of the variable called tenure after all the conversion. So, now we have replaced 4 by 4 and ONE by 1. So, now you can see after replacing the tenure to a numerical variable, it is giving us the 5 number summary for the column tenure. The minimum tenure is 1 and the maximum tenure is 1008. Now, you can see there are no special characters as 4 and 1. It is only a numerical variable with the minimum value 1 and maximum value 1008. So, now we have cleaned the column called tenure. Let us move on to clean the column called dependence. So, we know that dependence should have only 2 levels, that is yes or no, but it has 3 due to the special character which has been read as another level. So, since the factor levels are locked, it is necessary to convert them to a character data type before changing the levels. Ideally, this column should be of a categorical data type, but we are converting dependence into character strings to unlock the levels. To convert to a character data type, we use the function called as.character. Inside that, we will access the desired variable, that is dependent, from the data frame called churn. And you can save that output to the existing data frame, that is churn. Access your dependent so that all the modification done here will be reflected in the dependence. So, now we are interested in replacing the special character by one of the categories of dependents. So, before replacing, we need to check the proportions of each categories under the column called dependents. So, we can get the frequencies of the variables, categorical variables, by using the function called table. So, here is the syntax for using the table function. The input should be your data frame. So, when we check dependents column using the table function, you can see there are 171 observations under no and only 73 observations under S. So, 1 at the rate of hashtag is the special character which we are interested in. It also has 6 observations. So, the maximum frequency is for no category. Now, we have seen the output in terms of numbers. If we want to represent the table entries as proportion of numbers, we can use the command called prop.table. This is the syntax for prop.table. Prop.table is the function. The input should be your table from which you want to represent the numbers in terms of proportions. So, here we are using the prop.table function. So, inside the parenthesis, we are specifying the table command which I have shown you in the previous slide. So, here the first bracket will give you the frequencies under each categories. By adding prop.table to that, it will give you the numbers in terms of proportions. So, here only 2% have special characters, but 68% of the observations are of no category and 29% are of S category. So, the highest proportion is for no. So, now we are going to replace the invalid characters in dependents. That is, we are going to replace the special characters by class no, which has the maximum count. For that, we are going to use the if else function. If else is the function here. The condition is from the data frame churn, wherever my dependents column having the special character 1 at the rate of hashtag, replace them as no, otherwise retain the existing values. Now, I am saving that to the existing variable dependents from the data frame called churn. So, now we have replaced the inconsistent characters. We are going to convert dependents to a categorical variable after replacing. So, to convert them to a categorical variable, we can use the function called as.factor. Inside the parenthesis, specify your data frame followed by the variable dependents. So, by using this command, our column dependent has been converted to a categorical variable. Now, we are going to verify if the special characters were converted to desired class or not. So, we are going to use the same function called table to get the frequencies under dependents column. Now, you can see all the special characters has been replaced as no. So, that we have 177 observations under no and 73 observations under S. So, now we have cleaned the column dependents. So, in this lecture, we have seen how to join the 3 files and we have looked at the basic structure of the data and we have also looked at the summary of the data to get the frequencies for categorical variable and to get the 5 number summary for a numerical variable, and we have also cleaned the variable called tenure dependent which has inconsistent characters. We have replaced them with the desired values.